Let's take a look at the database for a second, and specifically at the members database table, as there are several points there to be made. We may notice that this table has a particular table field that normally doesn't belong there and should never be saved anywhere in the database, but we keep it there anyway for debugging purposes. This field is called debug, but what it really contains is the same row user's password in plain text. Again, this information, namely a user's password, should never be kept anywhere in the database for security. The reason it is here, though, is to make it a bit easier for us, as developers, to be able to perform various tests with multiple user IDs without having to remember the password for each and every one. On the other hand, this application does use the correct way to verify a user's password while keeping it safe. This is accomplished by using a hash string, as we may notice on the left side of that column, namely p-hash, which in here is a short for password hash. A hash string is practically a form of an encrypted representation, likely a differently looking one, of some other plain text string. A hash string may be produced using a special mathematical algorithm known as a one-way hash function, which, in the code, is referred to as the built-in getHashCode function. What this means is that if, for example, we said that A were our plain text string, and B were the new hash string, then given A, the function would yield B. However, given B, this function running inversely, or any other equivalent inverse function, would not be able to recalculate A back. This is ideal for password safekeeping. Every time that a user types in their password on the login page or new member registration page, all we need as developers is to run a hash function for it, thus produce a hash string for that password, and then either keep it in the database for the first time in case of a new user, or compare it to a previously saved hash for an existing user without ever having to reveal the original plain text password. It is important to point out, though, that the best practices for keeping all data in the database safe would really involve data level encryption of each and every value in each and every table field in each and every database table. Thus, if the database gets hacked into, then all of the values would prove to be completely useless for the hacker, as they'd all appear to be junk and nothing more. In here, however, all data values are in plain text for demonstration purposes. Now, should the members database table be compromised somehow, assuming that the debug column and all of its data had been tossed out prior to on-site deployment, then anything that would ever be available in the open are only the user's hash strings. And, because those hash strings have been produced by a one-way hash function, they cannot be restored into the original passwords, which means that the passwords themselves would remain safe. In other words, if we were to examine how this task gets carried out in the code, it'll take the following 3 steps. Let's say that user 23 is looking to log in to their account. 1. A given password of 123456, which is a plain text string, will be put by the application through the getHashCode function. 2. This getHashCode function will perform some calculations and return 184919035, which would be a new hash string. 3. This new hash string may now be compared to a previously saved hash in order to determine whether or not user 23 should be allowed in. Running this function inversely by a hacker, however, is not going to yield the original password back. If we were to repeat those 3 steps we would find out why. 1. A given data piece of 184919035, which, for all we care, could be of either type, a plain text string or a hash string, will be put by the application through the getHashCode function again. 2. This getHashCode function will perform its calculations and return -362069063, which would not be the original plain text password. 3. How do we know that? Simple. By comparison, a hacker's attempt to make use of 184919035 for their password would have the application calculate a hash string different from the previously saved one, and therefore the hacker will not be allowed access. And most importantly are 1. The original password has remained unknown to the hacker all along. 2. The so-called hacked password was entirely useless. Now, for this particular member, namely user23, we will notice a few other things as well. 1. They're currently logged out. And how can we tell? The value on their is in column is set to 0. It would be set to 1 to designate the opposite, meaning a logged in status. 2. There isn't a session ID value available because of this logged out status. 3. The last time they logged out was earlier today, meaning on December 5th, 2014 at 11:49 a.m. 4. They don't have a whole lot of money on their virtual credit line. In fact, a mere $130.23, to be exact, is what's left. Okay, let's log in as user23.